must have you must have knew what some of you must have completed BSc in chemistry, or all of you. So and some of you are doing job also. So what happens in electrochemistry? We know there are two electrodes. One is cathode, another is anode. Okay, so just now I'm going to share. Just a minute. Give me a minute. So my screen is shared, right? Hello, am I audible? And my screen is shared, na? All of you are getting my screen.
Yes, sir.
Okay. So this is the electrochemical energy systems. This is the what is first of all. If you scroll your book, that is whatever you received the book one, electroanalytical methods. So the very first page it is there. What is electrochemical cell? A setup in which decrease in free energy accompanying a selective indirect redox reaction is converted into electrical energy is known as electrochemical cell, or sometimes galvanic or voltaic cell. What is the meaning of this? The meaning of this is in electrochemical cell, the chemical energy is converted to electrical energy. The first and foremost, what is the conversion of energy? Okay, what energy converted to what energy? The chemical energy converted to electrical energy. So it is a redox reaction. What do you mean by redox reaction? Because here, just a minute, your cathode is reduced and anode is oxidized. Okay, that's why altogether it is a redox reaction. Okay, so student, just see this diagram. Uh, this diagram you see in this diagram, here the very left side is the jaw. Where is my cursor? Where is my cursor? That is the gray color rod or slab is zinc. That is below this it is written anode, and this side you see that is a another electrode, that is SHE, standard hydrogen electrode. It is there. Okay, this is standard hydrogen electrode. I will also teach you what is standard hydrogen electrode. So what is this? So in the here this all together, when they joined, they are constituting a cell. In this cell, zinc is anode and SHE or standard hydrogen electrode become cathode. Okay, so here zinc is dipped in aqueous solution of zinc sulfate. Here zinc sulfate is the electrolyte, and here the SHE is dipped in copper sulfate. Okay, copper sulfate is the electrolyte. Okay, for the example I can give you another diagram which will be more relevant, and that will be which one, just a minute. It is not there here. No, same diagram is there also. So I wanted to show you the zinc and copper, where it is actually. Okay, let it, no problem. So here it is your the first electrode is very clear. That is your, you can say it is so if you do like that, are you getting, student? Hello, hello, student, are you getting?
Yes, sir.
This is zinc, this will be copper, and it is, the solution will be zinc sulfate, and this solution will be zinc sulfate, and this solution will be copper sulfate, and it has been observed that electron is flowing from zinc to zinc to copper. Electron is flowing in this direction. See here how here it is written electron is flowing from a zinc to SHE, like that. In this electrode, zinc is electron is flowing in this direction. In the electron is flowing in this direction, and here the electrons flow, and the current flows in this direction. Okay, so first of all, what you will remember from this slide, every electrochemical cell made up of by two electrodes, one is cathode, another is anode. Cathode is always placed by sign convention in the left side, and cathode is always placed in the right side, and anode is always placed in the left side. And anode always loses electron and become oxidized, and cathode always gains electron and become reduced. Every cell is made up of two half cell or electrodes. Every half cell is known as electrode. This electrode is known as cathodic half cell. This electrode is known as anodic half cell. Okay, so this electrode is known as cathodic half cell and anodic half cell. So every cell is made up of two half cells or electrodes. The electrode used for oxidation is called anode. See here, anode. While that used for reduction is called cathode. By convention, anode is placed at the left side and cathode is at right side of the setup. Connection is made through a conducting wire in the outside circuit, while by a salt bridge. Salt bridge. This is the salt bridge, student. Which one is salt bridge? You know. This is the salt bridge. See here, this is the salt bridge. The salt bridge, which provides the electrical neutrality, uh, so that the cell reaction continues. Okay. So coming to, suppose, student, let which one? Just a minute. Just a minute. Suppose I told you, as I told, suppose this is your, this you have taken what? This you have taken as zinc. This is your, student, Zn. This is your copper, and the solution is zinc sulfate, and this solution is copper sulfate. All are aqueous. This is also aqueous. Okay, and this is the salt bridge to maintain the electrical neutrality, and this is the circuit. Okay, the electron flows in this direction and current flows in this direction. Okay, and this is your anode, and this is your cathode. Okay, student, are you getting? Okay, now if it is going on, then what is the reaction? What is the reaction after doing? What is the reaction? What reaction is going on? What reaction is going on here? See what is the reaction going on? Zinc in this, students, in this half cell, in this half cell, in this half cell, this half cell, uh, this half cell, zinc oxidation state is 0. This zinc oxidation state is 0, Zn 0, and here also copper 0. Okay, but inside the solution who are there, inside the solution copper 2 plus is there, copper 2 plus aqueous. From where it has come, from copper sulfate it has come, and the zinc rod is the rod which is electrical neutral. Okay, so student, here see here, the zinc, the zinc, this is the zinc, okay, which is getting oxidized, Zn2 plus releases 2 electron. This is oxidation or loss of electron, and a reaction at cathode, copper 2 plus from the solution receives these 2 electron whatever coming from zinc, and it is added here and become copper 0, and deposit on where it will deposit, it will deposit here, student, it will deposit, it will deposit here. Okay, here the copper weight will gradually, here the copper weight will gradually increase, this will gradually increase, and the zinc weight, zinc rod weight will gradually decrease. Okay, so it is evident that during cell operation, anode acquires progressively positive charge while cathode acquires negative charge. As a result, anode does not further allow the movement of electron away from it, and similarly, electrode does not allow the cathode does not allow movement of electrons into it, and cell operation becomes to an end or comes to an end. Therefore, charge neutrality in both the compartment is an essential requirement for all operations. The purpose is satisfied by the use of salt bridge. It provides negative ions to anode and positive ion to cathode through selective adsorption method. Students, see here, I wanted to say you that. So what that means? That means in this electrode and in this electrode, and this is the zinc rod. Just a minute. This is another copper rod. This is copper. This is copper. This is zinc. So zinc, this is student. This where is my cursor? So this is zinc. Okay. So this zinc uh, become 2 plus 2 electron. What reaction is going on here? Zn gives Zn 2 plus 2 electron, and this 2 electron moves through this, reaches here, and in this solution copper 2 plus is there, and copper 2 plus and sulfate 2 minus, both are there. Sulfate 2 minus, copper 2 plus accept 2 electron, become copper neutral or solid, and deposit over deposit over here, deposit over here. Okay, so student, what will be left in copper electrode? Sulfate. And in case of zinc electrode, what will be left? Zn2 plus. This half will be full of Zn2 plus. This half will be full of sulfate 2 minus. So student, so if when the sulfate 2 minus will more, because all the copper 2 plus deposited over here, and here Zn2 plus are more because all the electron are moving away. So what will happen? This rod will stop uh, giving Zn2 plus. Why? Because the Zn2 plus will repel, this Zn2 plus will repel further incoming of Zn2 plus. This become a positive hub, and this become a negative hub. Okay, this become a positive hub, this become a negative hub. Okay, so student, how to do the reaction, how to continue the reaction? To continue the reaction, you have to put a salt bridge, you have to put a salt bridge. The salt bridge will give you, so this, the salt bridge is such a species, it will provide, it will provide ions, it will provide ions. Okay, So it will provide K plus I, K plus ion here and Cl minus ion to here, because Zn2 plus in this half shell is more. The Zn2 plus become zinc chloride and become stable, and here sulfate 2 minus accepting K plus become potassium sulfate K2SO4. So that the electrical neutrality will maintain and the cell reaction will going on. Okay, student. Hope you got it. Student, are you there and are you getting me? Whatever I told up still now. Hello. May I get answer from anyone else? Am I connected to connected or not?
Yes, sir. Connect.
Okay. Thank you. So students, first of all, if you pick one of the electrochemical cell around you, that means there are two half cells or two electrodes. One is anode, another is cathode. Anode is always oxidized. Metal become M plus and plus electron, and the cathode is always reduced. So reduce, who is reducing? Cathode. Around the rod in cathode, around there is a solution, there is a electrolyte solution. The solution contains and solution contains a metallic ion. That metallic ion accepts two electron. So the whatever I discussed, the metallic ion surrounds to cathode is copper 2 plus. Copper 2 plus kahan se aaya? From where it has come? Copper sulfate. Copper sulfate aqueous solution gives copper 2 plus and sulfate 2 minus. And copper 2 plus from the aqueous solution receives 2 electron, which is coming from zinc electrode, and become copper and deposit over here. Are you getting me, student? Right? And zinc electrodes oxidizes itself. Okay, so student, now you came to know that who are the essential requirement for for electrochemical cell: two electrodes, two electrolytes, one connecting wires, and that is a voltmeter which or ammeter which measures the current, and voltmeter which that is a, we have to what create a potential difference, so by using a battery, so that the cell reaction will continue. Okay. So sign convention: anode provides electron during cell operation, and is electron rich, while cathode always has demand for electrons. Therefore, anode is always assigned with negative sign, while cathode with positive sign. And current flow from positive terminal to negative terminal. It should be noted that anode represents an electrode through anode represents an electrode through electron goes out from the electrolyte, and cathode represents one through which electron enters into the electrolyte. Got it, student? If you say yes, then only I will proceed. Hello? Whether I am there or not, student? Yes. Actually, whoever is writing yes, your mic is not working. So, actually, I cannot come to the screen always to see your message. Okay. Anyway, now student, we will ask for the your book. We'll go for what are the different types of electrodes are there. So based upon the total electrodes, uh, electrodes are categorized into four types: type 1, type 2, type 3, type 4. So type 1 electrode, these electrodes are reversible with respect to the electrode material: metal, ion, electrode, gas, metal ion electrode, gas electrode, and amalgam electrode fall in this category. Okay, students. So if I will say, uh, just a minute, I will teach you one electrode only. Then rest of the electrode you will understand as per the. Student, this is suppose an electron. Sorry. Suppose this is completely a metal. This is metal dipped in its own solution, own MX aqueous. Example: zinc solid dipped in zinc sulfide. So when metal is uh, in contact with its own ion, this solvent contains M N plus ion. Okay. So if, listen student, I am not discussing this electrode become cathode, this electrode become anode. This electrode may cathode, may anode. When it is cathode, the representation, when it is anode, the representation will be M oblique Mn plus, that is oxidation. Here to here is oxidation. And when it is cathode, the representation will be like that, like that. This is reduction. And when it is anode, that means when it is anode, the reaction is, when it is anode, the reaction will be M solid gives M N plus N electron. When it is cathode, it is reduction. The reaction will be M N plus N electron become M solid. So student, metal, see here what is written. Metal dipped in its own metallic ion. That is means metal ion, metal electrode. See here, these electrodes are reversible with respect to the electrode material. That means here the electrode material is zinc. Here the electrolyte contains Zn2 plus. These electrodes are reversible with respect to the electrode material, metal and electrode gas. What are the examples? These are the examples. So see here I have written zinc electrode when it is acting as anode. This is acting as anode. This is the reaction. And when it is cathode, this is the reaction. When it is anode, the representation is this one. When it is cathode, the representation is this one. See here. Okay, student. So you got. So now come to the gas electrode. So student, gas electrode is such an electrode. Gas electrode. This how? Just a minute. So glass electrode is such an electrode. See here. Suppose you will take this is your hydrogen gas at 1 atm pressure. This is your HCl. H plus concentration is 1 molar. 1 molar. And this is platinum foil. And this is platinum wire. Okay. So student, this, that means here hydrogen is acting as an electrode. Here hydrogen is acting as an electrode. Hydrogen acting as an electrode. When it is acting as electrode, So it may be cathode, may anode. So when it is anode, the representation will be platinum, comma H2 gas oblique H plus, and the reaction is half H2 gives H plus plus electron. And when it is cathode, the representation will be H plus oblique half H2 comma platinum, and the reaction will be H plus plus electron become half H2. This is reduction. So then my motto is to say that gas and inert metal. Who is the inert metal here, student? Platinum is the inert metal. This is the platinum foil. See here. This is the platinum wire. Already I told you. This is the jacketed glass. This is the hydrogen gas. So here completely where this is the hydrogen. Here there is a coating of hydrogen over this inert gas. Where is my pen is moving, there is a coating of hydrogen gas above this inert gas. The inert metal only this inert metal only to conduct electricity, only to carry electricity. It has no role in the chemical reaction. So this is the simply it will written platinum. Half H2 is the gas electrode. In the place of just remember, in the place of zinc, in the place of zinc, here what is written? Here hydrogen is written. In the place of zinc 2 plus, what is written? H plus is written. This is your anodic representation, and this is the reaction, and this is the cathodic representation, and this is the reaction. So students, somebody's mic is on, so he can say or she can say whether it is you are getting whatever I am saying.
Yes, sir.
Okay, very good. So student, type 1 another electrode is coming, that is gas cadmium amalgam electrode. So cadmium amalgam electrode, which is another type 1 electrode. See here, the representation is CD hyphen Hg. That means cadmium is reactive, its reactivity is become diminished or decreased by coating with mercury. This is the mercury which is coated. So up to from here to here is platinum rod, and from here 1 minute, from here to here, this where is the yellow color, it is cadmium. This is cadmium coated with mercury, and around this total it is full of cadmium sulfate. Okay, so the solution has inside, this is the solution, this is the solution, it is having Cd2 plus ion, Cd2 plus ion. Okay, so cadmium solid, if the electrode become your student anode, this is the representation cadmium. So what is this to this is oxidation. So cadmium, because mercury will not take part in the reaction, cadmium gives cadmium 2 plus plus 2 electron, become oxidation. If it is anode, then this is the reaction. If it is cathode, then who will be the reaction? This is the reaction. This is the representation. This is the reaction. Are you getting me, student?
Yes, sir.
Okay. Now coming to the your just a minute. Now coming to your which one? Type 2, you're having calomel electrode in your syllabus very much. Okay, calomel electrode, it is in your syllabus very much, it is there. So I want to teach you calomel electrode. So student, calomel electrode. Calomel electrode means mercury, platinum, mercury, liquid, Ag2 plus. This is the anodic representation. Anodic representation, and the cathodic representation is this is the cathodic representation. But student, what is actually I have written very straight, but it is not like that. Calomel electrode is such as electrode. It is having two electrolyte. See here. Where is my cursor? You just see. Ag is the liquid metal. AgCl2 is a insoluble electrolyte. KCl is a soluble electrolyte having common anion. So who are the common anion? Cl minus in KCl and Cl minus in Hg2Cl2. Both are common, students. See, Ag2Cl2, Hg2Cl2. This is uh, an electrolyte which is very weak and it is water insoluble, and KCl is a strong electrolyte which is water soluble. Okay, student. So this is the calomel electrode. So calomel electrode, who, if you want to write, okay, so it will be like that. Mercury, platinum, comma, mercury liquid, oblique, Ag2Cl2. This is solid, comma, KCl. This is your anode, and cathode will be KCl, comma, Ag2Cl2, solid, oblique, Ag liquid, comma, platinum. Student, this is the cathode. So cathode always the opposite of anode. Always you represent like that. See here, student, how I will tell. Anode, this is the anode. The representation is C. He only the mercury, the platinum word is missed here. It should be written platinum. Here it should write platinum here. Student, once mercury oxidize, it become like that when it is anode, and this Ag2 plus is unstable. It will take 2 Cl minus from where? From this KCl, become Ag2Cl2, and this is the oxidation reaction. Oxidation reaction means electron will always appear in the right side with a positive sign. See here, the positive sign. If you want to put the electron here, it can be written like that, minus 2 electron. Either you can write minus 2 electrons, or you can write plus 2 electron here. Then in cathodic reaction, KCl plus Ag2Cl2 Hg. So cathodic reaction, Ag2Cl2 become Ag2 plus 2 Cl minus, and Ag2 plus receives 2 electron, becomes 2 Hg, and this is the overall reaction. So in case of reduction reaction, the electron is always with a positive sign in the left side of the equation. Okay, this is the reduction. When electron is utilized, it is reduction. Utilized means it will be acting as a reactant, and when an electron is a product, that means it is generated, it is oxidation or released. Are you getting me, student? Please say yes or no.
Yes, sir.
Okay, very good. So this is your calomel electrode is very much in your syllabus. Okay. So similar to this calomel electrode, this is silver chloride electrode. Just a minute. This is your silver chloride electrode. See here, what is the no? You know, metal means metal. This is silver. Here, no platinum is required. Why? Because mercury. The last slide. Mercury is a liquid. So how we can bind wire in liquid? How we can send current to liquid? So by the help of a inert metal. Platinum only conducts electricity. See, total reaction from here to here, you see, nowhere, nowhere which is used, nowhere platinum is taken part in the reactions. Are you getting me clear? Platinum is only conduct electricity. But here silver itself, here silver itself is a metal. Silver metal dipped in its own insoluble salt. AgCl is an insoluble salt. KCl is a soluble salt having common anion. KCl and AgCl having common anion, that is Cl minus, Cl minus. Cl minus is a common anion. Okay. So similarly, when the reaction, when the same electrode become cathode, this is the reaction Ag gives Ag plus. When the same electrode become anode, this is the representation. This is the representation. Ag solid gives AgCl, KCl. See, just student, Ag to AgCl. What is the oxidation state sense? Ag means it is oxidation state is 0. AgCl means oxidation state is Ag plus. So 0 to plus is oxidation. So this is your anode. Ag gives Ag plus electron, and Ag plus Cl minus. Students, my question is to there, from where the Cl minus is coming, from where the Cl minus is coming, from this KCl. Only KCl is there to accelerate the reaction, because once Ag plus form, it is very unstable, so it becomes stabilized by forming AgCl. So Cl minus will come. So if Ag plus is there, somebody is there to stabilize Ag plus, then Ag will say that, Ag solid will say that, yes, I will form Ag plus. If it is not stabilized, then Ag solid will not give Ag plus. Okay, it is there to stabilize by what? By Cl minus. Cl minus to become AgCl, and this is the reaction AgCl plus electron. Then cathode. When the same electrode become cathode, this is the representation KCl, AgCl, Ag. That means AgCl, the oxidation state is of AgCl, oxidation state of Ag in AgCl is equal to Ag plus, and the oxidation state of Ag solid is 0. That means plus to 0 means accepting electron. So here electron is accepted, becomes a reactant. Here electron is released, become a product. So here it is oxidation, here it is reduction. So coming to this one, your SHE, this is very much in your syllabus. Okay. So student, so a reference electrode, which is already I told you some extent about SHE, but this is the mostly the general syllabus. Standard hydrogen electrode, which is a primary reference electrode, and its reduction potential as well as oxidation potential is taken at 0.0 arbitrarily. The student, when a electrode is called as a standard hydrogen electrode, when a normal hydrogen electrode, that means He means hydrogen electrode, will be called as a standard hydrogen electrode. Standard hydrogen electrode, uh, just a minute. Already I have given you the diagram. Still, what is the difference between SHE and HE? Already I have done the diagram, student. Actually, this should be inside the container. This is your hydrogen gas, 1 atm pressure. Inside this HCl solution is there. and the concentration of HCl is equal to concentration of H plus, that is 1 molar. So can student anybody say what is 1 molar? What is meaning? How many number of what is the amount of HCl present in 1 liter solution to give a strength of 1 molar? My question is what is the amount of HCl should be there in 1 liter of its aqueous solution? Then only the solution will be called as 1 molar. Can anybody say? This is platinum wire. This is the platinum foil. So student, this is the total setup of hydrogen electrode. Here the bubbles of hydrogens are here, the bubbles. That means this total wire is coated by hydrogen gas. Now hydrogen gas is acting as a metal like. So it is playing the role of electrode. It is playing the role of electrode. Okay. It is playing the role of electrode. So already I told you, if it is anode, the representation will be platinum, comma, half H2 in bracket 1 ATM. You have to mention. In normal hydrogen electrode you may not mention, but if standard hydrogen you have to mention. Then H plus, this will be 1 molar. This is your anode. The reaction will be half H2 plus minus electron. It become H plus, or half H2 gives H plus plus electron. So if it is anode, then if it is cathode, what is the reaction? If it is cathode, the reaction will be H plus plus electron become half H2, and the representation who can say? Half H2, 1 ATM, H plus 1 molar platinum. So see here student, in my slide H2 gas is 1 ATM, platinum wire is there, glass jacket is there. These bubbles are who are the bubbles? Hydrogen gas, and the concentration of hydrogen ion is 1 molar. This is platinum pearl standard hydrogen electrode. So students, what is the reaction? This is the reference electrode, is an electrode with standard potential. Reference electrode have two types: primary reference and secondary reference. Standard hydrogen electrode is used as primary reference electrode. The representation of the electrode is platinum, half H2, 1 ATM plus H plus. This is your anodic representation at 298 Kelvin temperature as anode, and schematic representation is given already. Here platinum wire is used for the conduction purpose and is mentioned always on the gas side, as gases are poor conductor of electricity due to lack of charge carrier. Platinum foil coated with platinum black facilitates electrode reaction by only providing the surface with the active sites. The potential of SHG arbitrarily fixed as 0.0 volt in at all temperature, irrespective of the irrespective of the value of temperature. The potential of SHG, either oxidation or reduction, is 0.0 volts. The student, why it is what is the limitation of hydrogen electrode? It is a standard hydrogen electrode. It is difficult to maintain uniform pressure of 1 atm and unity concentration of H plus, that is 1 molar for throughout the operation, and difficult in handling. It is not portable, readily poisoned by compounds like mercury, arsenic, sulfur, and oxidizing agent like permanganate ion, dichromate ion. Okay. If somehow the hydrogen electrode is coming in contact with the mercury, arsenic, sulfur, it become contaminated, and somehow it is also coming in contact with dichromate, permanganate ion, it also become contaminated, and it is not handy, it is not portable, and the maintenance of 1 atm pressure throughout the operation and the maintenance of 1 molar concentration of H plus throughout the operation is difficult. That's why again, who are searched? The secondary reference electrodes are searched. Looking into the difficulties encountered with SHC in regular practice, the use of secondary reference electrode is promoted. The potential of this electrode is obtained with respect to primary reference electrode, that is calomel electrode, silver chloride electrode. Okay. The student, suppose you have discovered an electrode. Suppose you have discovered an electrode. So whose you have discovered an electrode, or you have an unknown electrode, you want to know its potential, either oxidation potential or reduction potential. You want to know its potential, student, either oxidation potential or reduction potential. Just listen my word carefully. So you have an unknown electrode in your hand. You want to know its reduction or oxidation potential. So how to know the reduction or oxidation potential, student? Just listen carefully. So then you require SHE, standard hydrogen electrode. So this is your unknown electrode. My left hand is unknown electrode, my right hand is known electrode, that is SHE. So I coupled, okay, I make a cell just like the image, In the image, the right hand side is SHE and the left hand side is the metal, which is unknown. Again, fortunately, I connected everything. Then I have seen that current is flowing from hydrogen electrode, that is standard hydrogen electrode, from right side to left side, which is the unknown metal. Okay, that means yes, my placement is correct. Means my hydrogen electrode is acting as cathode and my unknown electrode is acting as anode. That means if some unknown electrode is acting as anode, that means it is possessing more oxidation potential than SHE. Okay, that's why it become automatically become anode, and electron is flowing from SHE to the unknown electrode. Okay, see here, here the just opposite. Here just opposite. That means after connecting after connecting, the standard hydrogen electrode with the metal, it has been seen. The diagram is whatever I'm saying, that is completely opposite is written in the diagram. So first, let me to finish whatever I am saying. So suppose your hydrogen electrode is this right side, left side is your unknown electrode. You have connected. Don't see, look the diagram. Connected. Then you have seen current is flowing from your hydrogen electrode to your unknown electrode. That means your unknown electrode become anode and your hydrogen electrode will become cathode. Now you find out your E cell. What is there is a this VTVM. Here it is written VTVM will give you the V cell. What is the output of the cell? The output of the cell will give you the electrode potential of the unknown electrode. Okay. I will also say you the calculation, but I will also teach you the calculation. Secondly, student, coming to the diagram. Come to this diagram. In this diagram, so I picked unknown electrode, metal electrode. I picked SHE. I joined. Unknowingly, I put hydrogen electrode in the right side and the metal electrode in the left side. But I found that electron is flowing from hydrogen electrode to metal electrode. That means my hydrogen electrode or standard reference electrode is become anode. So it has to be like that. It has to be like that. But what I placed already, so I cannot remove it. If there is chance, then I can tilt it or let it be there. Okay. So now I have seen that current is flowing from SHE to my metal electrode, which is unknown. My metal electrode is here acting as cathode and my SHE is acting as anode. Then find out the E cell from by the VTVM. VTVM will give you the E cell value. What is the output of the cell? The output is equal to E cell is equal to E cathode minus E anode. Okay, then only you will be getting the either oxidation potential or reduction potential of the metal or non-metal. Okay, so students, when the metal are coupled with, when any unknown electrode is coupled with SHE, standard hydrogen electrode, the oxidation potential, sorry, the reduction potential is mentioned here. The table which represents the reduction potential of the unknown electrode by coupling with primary reference electrode or SHE is known as electrochemical series. This is the electrochemical series. Fluorine F2 plus 2 electron become 2F minus the standard potential reduction. This is addition of electron, and here addition of electron means reduction. Here everywhere addition of electron means reduction. So this is the standard reduction potential of fluorine is plus positive 2.87. Lead plus 4 to lead plus 2 is positive 1.67. Chlorine to 2Cl minus is 1.36. Oxygen to water it is positive 1.23. Silver to silver, silver plus to silver it is 0.80. Fe3 plus to Fe2 plus is positive 0.77. Copper 2 plus to copper positive 0.34. Hydrogen 2H plus to H plus or H plus to H plus H2 it gives 0. This is the very important. Okay. Then Pb2 plus to Pb it is negative 0.1. See, start negative started from here. From here negative is started. From here negative is started. Zinc 2 plus to zinc, that means zinc is not interested. Negative means they are not interested to be reduced. They are interested to be oxidized. Positive means they are interested to oxidize. Negative means they are not interested to, they are interested to not oxidize, or they are not interested to oxidize. They are interested to, see here. Negative means Zn gives Zn 2 plus 2 electron. The here it is oxidation, student. So the standard oxidation potential of what is the eraser? The standard oxidation potential of is equal to positive 0.76 volt. See here, the standard reduction potential of zinc is negative 0.76. That means if a standard reduction potential, if listen students, see here, if zinc solid gives zinc 2 plus aqueous plus 2 electron, it is oxidation. So E not means standard, Zn2 plus is equal to positive 0.76 volt. Same Zn2 plus 2 electron become Zn, and E naught Zn2 plus 2 Zn is equal to negative 0.76 volt. Student, are you there? Are you getting me whatever I am teaching? Hello?
Yes, yes, sir.
Okay. That means, student, a metal, if it is possessing positive oxidation potential, that means it is interested to oxidize. So if zinc the oxidation potential is 0.76 volt, that means zinc Zn solid gives Zn2 plus 2 electron, and the oxidation potential is 0.76 volt. Positive means it is interested to be oxidized. At the same time, if I will ask you what is the reduction potential of zinc, you will write Zn2 plus aqueous plus 2 electron gives Zn solid. So the reduction potential of zinc is equal to minus 0.76 volt. So that means zinc is not interested to be reduced because it possesses negative reduction potential. So it is not interested to reduce, but it is not all the cases. Situation, what situation will uh, what the situation will be, accordingly the metal will behave. Okay, so if the situation, that means, student, I'm saying that if you want to couple silver with, sorry, copper with zinc, copper possesses reduction potential positive. See here, copper possesses reduction potential positive. See here, where is my cursor? My cursor is here. See, copper versus reduction potential 0.34 0.34 volt. This is copper, this is zinc. So zinc become anode because it possesses negative reduction potential. That means positive oxidation potential. So automatically the current will flow from copper to zinc, and the electron will flow from zinc to copper. But student, at the same time, if I will say, see here, if I will say your silver possessing positive 0.80 volt and your copper possessing positive 0.34 volt, both are possessing positive reduction potential. Both are possessing positive reduction potential, but silver possesses more reduction potential, that is 0.80, and copper possesses less reduction potential, that is 0.34. So copper become anode and silver become cathode. Same copper, when it was anode cathode with zinc, same copper become anode with silver. Got it, student? Hello. Okay, done. So then coming to the Nash equation, which is a very suppose student, I before going to Nash equation, I want to say something to you that will be
Hello,
yes.
sir. This is a oxidation potential or a reduction potential?
No, I am discussing reduction potential. Here I have whatever I have shown here.
Hmm. It's a
Here
reduction. You
this is
told me.
reduction.
You told me it is a oxidation potential.
No, no,
It
no,
is a
no.
reduction. It
It
is
is
a reduction
reduction.
potential.
It can be converted to oxidation. That means if somebody will ask you by looking the value, if somebody will ask you what is the oxidation potential, you can also add a negative sign.
Okay.
My question is, this is the only value you have to remember,
Okay.
and that value will help you to give you all data. That means if you know reduction potential standard, which is positive, if I will ask you what is the standard reduction potential, you just simply add a negative sign.
Okay.
Put a negative sign. Okay.
Okay. Okay.
Okay. So no need to remember all those things. Only you have to remember either positive or reduction or negative. Sorry, either oxidation or reduction. Here completely this is standard reduction potential. It is completely standard reduction potential. So coming to the North equation, student, which is very helpful during your this paper, because North equation it is there in your syllabus very much. So North equation, before doing North equation, student, so if I will consider this is a cell, already I told you so many times, this is zinc, this is copper, and this is your zinc sulfate, this is copper sulfate, and the representation is Zn solid oblique Zn 2 plus salt piece copper 2 plus oblique copper. So many things I am missing. That means I am missing aqueous. Okay. So what is the reaction? The reaction at anode. What is the reaction at anode? Zn solid gives Zn 2 plus 2 electron. What is the reaction at cathode? Copper 2 plus 2 electron become copper. What is the net cell reaction? Net cell reaction. These two electron will cancel. Zinc solid plus copper 2 plus aqueous will take Zn2 plus aqueous plus copper. This is the net cell reaction. So which is a, so student, it is a reversible type of reaction. So student, then if what is the um, when just a minute, see here, let us consider a hypothetical cell reaction. AA plus BB gives CC plus DT. So here del G is equal to del G naught as per the Van reaction isotherm. This reaction, this equation we borrowed from thermodynamics. So I think thermodynamics is one of your paper. I think so in your PGDSE program. So this is from Van isotherm, and this Q represents the reaction coefficient. So student, why I have written this reaction here? Q, here Q will be, what you know, here Q will be Zn2 plus concentration, which is a reactant, by copper 2 plus concentration, which is a product. We will not consider the neutral species, that is, will not consider the neutral species, that is Zn2 Zn, will not consider the neutral species, that is copper. Only we will consider the charge species. Getting, student? So when you will calculate the reaction coefficient Q, it will be Zn2 plus concentration divided by copper 2 plus, means the ionic term present in the product side divided by the ionic term present in the reactant side. Got it, student? Got it? So see here, in this reaction, it is in generally written. Here in this reaction, all the things are taken here. Okay, but here no ionic species is mentioned, which is overally correct, actually incorrect. Here we have to consider, this is Q, this is nothing but Q. Here we should consider the ionic species, the concentration of ionic species in the reactant side, product side, divided by the concentration of ionic species in the reactant side. This is the product side, this is the reactant side, only ionic species. Okay, student? So student, this equation del G is equal to del G naught plus RT ln Q, this we borrowed from Hunter isotherm. Okay, so at exact equilibrium, student, at exactly equilibrium, Q is equal to K and del G equal to 0. So that's why at equilibrium, exactly at equilibrium, this reaction, this equation will be 0 equal to del G naught plus RT ln K. Instead of Q, we'll write K. Instead of del G, we'll write 0. Instead of del G naught, it will be as such, del G naught. So del G naught will be minus RT ln K. Okay. So del G, student, again I will say thermodynamics and electrochemistry, they are interrelated. Del G, that means change in free energy, is nothing but minus NFE. So what is, who can say, what is the meaning of del G naught is equal to minus del G is equal to NFE? What is the meaning? And NFE minus NFE is equal to del G naught. What is the meaning? Today in the very first line I told that chemical energy is converted to electrical energy. So the conversion of chemical energy, this is the line wherever I am writing. The conversion of chemical energy sorry, to electrical energy. This conversion, that means the decrease in chemical energy, that's why it is a negative sign. This negative sign represents decrease in chemical energy. Chemical energy nothing but del G. Here the not term is not there. 1 minute. This not term is not there. Okay, del G is equal to minus del G is equal to NFE, or minus NFE is equal to del G. So suppose a electrochemical reaction, you are getting some chemical energy. Electrochemical reaction, you are getting some chemical energy. Suppose in a electrochemical reaction, you are getting some chemical energy. That means this is the reaction. That means the electric energy decreases, you are getting chemical energy. Here the chemical energy decreases, you are getting electrical energy. So minus means the decrease in chemical energy and appear in the form of increase in electrical energy. Student, coming to this slide, see here, In the place of del G, I have written minus NF. In the place of del G naught, I have written this to this. The equation directly from this to this to this. Instead of del G, I have written NFE minus NFE. Instead of del G naught, I have written minus NFE naught. NFE naught. See here, we have written this both the things, and this is Q when it is in normal condition, and then I have divided NF in both the sides. NF I have divided totally by NF. This NF cancel, this NF cancel. Here NF will be coming here, as it is here, and you got this one. So at temperature T is equal to 298 Kelvin, R ka value 8.314 Joule Kelvin inverse mole inverse, F is 96500 Coulomb. Then you got this is equal to this. This is your extended version of North equation. Okay, student. So calculation of electrode potential using North equation. Electrode potential. See here, electrode potential, student. So just I want to do some calculation here. I don't know whether you are joined or not, and whether you are listening or not, or whether I am teaching the laptop only. So I happy that somebody asked me a question, but the question should be always. Otherwise, I will be hopeless. So see here. Suppose the reaction is like that. Already I have written the reaction Zn solid SL reaction plus copper 2 plus this Zn 2 plus copper solid. The Knox equation for this will be E. Here n is equal to 2, student. Who can say why n is equal to 2? Student, anyone is there? Who can say n is equal to 2? N equal to 2. What is n? N is equal to number of electrons involved. Yes, somebody switched on. Say me.
Yes, sir.
What is electron? What is n?
The number of electrons involved.
Means the redox reaction. Very nice. Redox reaction. Okay. So here in n equal to 2 or not?
Yes.
Very nice. So students, so the reaction will be E cell is equal to E naught cell minus 0.059 divided by 2 log of concentration of Zn2 plus divided by copper concentration of copper 2 plus. Okay, this is the I'll say you how you can calculate E naught cell. Okay, then another thing. Another thing I wanted to say you how it is electrode. Same North equation we can apply to electrode potential. So student, our electrode is given like that. This is an electrode, only electrode. This is the electrode reaction. So this is the only electrode reaction. So obviously n is equal to 2 as it is there. So here in the reactant side, this side no ionic species is there. In the product side only one ionic species is there. So applying North equation, applying North equation ये capital N होगा. So E Zn 2 plus 2 Zn is equal to E naught Zn 2 plus 2 Zn plus, no, sorry, negative 0.059 divided by 2 ln Zn2 plus concentration. इसके नीचे कुछ नहीं रहेगा, nothing will be there. Why? Because there is no ionic species. There is no ionic species. So it will be unity. So it will be unity. So students, this my motto is to say that the Nernst equation can also used to calculate the electrode potential. So this is the electrode potential, student. Here, whatever I taught you, student, that is I have written here. What I have written here, so you just see. What I have written here, just see. I have written here zinc solid gives zinc 2 plus. Zinc solid gives zinc 2 plus. Zinc solids gives zinc, here zinc solid was there previously. Zinc solid gives zinc 2 plus. But in this slide, what is there? Zinc 2 plus gives 2 Zn. That means opposite. So in the left hand side contains a ionic species, the right hand side doesn't contain any ionic species, it is 0. The oxidation state is 0 here. So the applying norms n is equal to same, n is equal to 2. Okay. So E is equal to E naught minus 0.059 by n log concentration of C, C, D, whatever. So here the ionic species in the reactant side, in the product side is no one is there. So you will take 1. You will take 1 unity. Okay. So in the place of these two, you will take 1 divided by, in the place of these two, you will take only Zn2 plus Zn2 plus concentration ln. So this is there. Activity. So this is, student, this positive, this negative become positive here because this come up. Getting, student? ये जो न्यूमेरिक, ये जो फ्रैक्शन है, ए जेड एन बाई ए जेड एन 2 प्लस, ये ऊपर चला गया तो यहाँ पे नेगेटिव साइन आ जाएगा, नेगेटिव नेगेटिव पॉजिटिव. समझ में आया? You got it?
Got it, sir.
Okay, just doing mathematics only. So the Nernst equations also help you to find out the reduction potential of oxidation potential of electrochemical. Student, now my question is, what is the value of this? Who can say? From where you will be getting? Who can say? From where you will be getting this one? Quickly. From the electrochemical series. This is the electrochemical series. See here. What is the value? What is the value?
0.76 negative.
Negative 0.7.
Negative 0.76.
Very nice. Very nice. So you will be getting the value of the standard reduction potential of any electrode from this electrochemical series. So in the numerical, it will be given. No need to worry. Okay. So simply represent a cell in which following reaction is going on. See here. Represent the cell in which following reaction is going on. Here magnesium solid plus 2 Ag plus gives magnesium 2 plus Ag solid. Okay. So anode, it and magnesium oxidizes. Who is oxidizing, student? Who can say? Who is losing electron? I wanted to know you. By looking the slide, please say me who is oxidized here.
Magnesium.
Magnesium. Who is reducing here?
Silver.
Silver.
Silver,
Very
silver.
good. So what is the number of electron involved in the redox reaction?
2 electrons.
2 electrons. What is the representation of the cell? Silver become cathode, magnesium become anode. This is the salt bridge. So this is your cathode, this is your anode. See here, this is the more detailed equation. Here I have written a negative sign over anode and a positive sign over cathode. The standard reduction potential of magnesium is negative 2.37 volt. It is given, and the standard reduction potential of silver is positive 0.80 volt. It is given. The question is, what is the cell potential? Student, what is the cell reaction? The cell reaction is this one. This is the cell reaction. Okay. Who are the ionic species present in the reactant? Who is the ionic species present in the reactant? Ag plus. Who is the ionic species present in the product? Mg2 plus. So student, this is the last equation, E equal to E naught. That means E cell is equal to E naught cell minus 0.059 by 2 log Mg2 plus to Ag plus power 2. Because number of before Ag, what is the number is there? What number is there? 2. So the power will be what? The power will be 2.
2.
Okay. So student, how can you calculate this one? The same E naught cell. This is equal to E naught Ag plus see here E naught Ag plus minus E naught Mg2 plus E naught Ag plus to Ag minus E naught Mg2 plus to Mg. या कैथोड से एनोड को माइनस कर दोगे, जो होगा तुम्हारा होगा ई नॉट सेल. इसीलिए दोनों दिया गया है. इलेक्ट्रोकेमिकल सेल से दिया जाता है, इसको कैथोड से हमेशा माइनस करोगे. यहाँ पे कैथोड को है, हु इज द कैथोड? तो सिल्वर इज कैथोड, हु इज एनोड? मैग्नीशियम इज एनोड. सो इधर से इधर माइनस कर दोगे. व्हेन यू विल डू डिडक्ट, you will be getting the value of E naught cell. E naught cell will be coming here, and you will just 80. The value will be 0.80 minus of minus 2.37. Okay. Then student, this is another application of SHG. This is the application of your North equation. Just a minute. So up to this you have clear, student, whatever I taught. Your application of North, 1 minute. Let me check whether this. Yes, this application is there. Last equation is there, delta G. Page number, whatever the book I am having, the page number 14, 15. So many numericals are there in your book. Page number 28 and 29 full of numerical, and it is also solved. You will see. Okay. So one thing, calculation of equilibrium constant is very much in your syllabus. That is very important. I should calculation of equilibrium constant. Using North equation. So student, you know the North equation for the reaction. Suppose I'm saying already you know. Q, where Q is equal to these are the this is the equation. Okay. Okay. This is the equation. So okay. So but when the reaction, when this is completely, when this reaction is in equilibrium, completely it is in equilibrium, K equal to Q. K equal to Q. This equation will be what? This equation will be what? Just a minute. So at equilibrium, there is no cell reaction. At equilibrium, there is no output. You have to remember these two things. At equilibrium, Q equal to K, delta G equal to 0, E cell implies E cell equal to 0. So the equation will be E cell के जगह में लिखेंगे 0 equal to E naught cell minus 0.059 divided by N log of K. So implies log of K is equal to N into E naught cell divided by 0.059. You have to remember the formula, student. The E naught, sorry, log K, that means equilibrium constant, is equal to N into E naught cell divided by 0.059. It is in your syllabus, 0.059. It is in your syllabus, page number, first book, page number. Whatever the book I am having, I am saying this one. You just check your book, calculation of equilibrium constant, page number 43, determination of equilibrium constant. Okay, student, you are having hard copy book or soft copy book? Hello, you are having hard copy book or soft copy book? Can anybody say?
Hard copy. Hard copy.
Hard copy. Okay, good. So in the hard copy, you just see. I have given. I have to. I'm book are assigned to me or whatever. Whenever I'm teaching, the books I kept in my side so that I can correlate. I can say you which part I am teaching. Okay, so this equilibrium constant, whether it is here or not, let me to check. Yes, to find the equilibrium constant from Notch equation, E is equal to E naught cell. E cell is equal to E naught cell 0.05. E completely 2.303 RT and F log Q. So at equilibrium, E is equal to 0, K is equal to Q. So this is become 0, this become, already I told you very nicely, this becomes 0, and this will be K. So this equation will be 0 equal to E naught 2.030 by NF log K. देखो ये 0 के वैल्यू किसके जगह में लिखा है, E naught E जगह में लिखा है. So this is with this, and this will be this. Wherever I reached in the slide in my writing, same here, it is landed here. Okay, it is landed there only. Then two numericals are there to find out the equilibrium constant. Just a minute. Okay, students, shall we continue or stop here? Hello. So generally the classes are continued till 7 o'clock, yeah, sometimes it is 6:30, it's over. Equal Ahmad, please. Yes,
3640.
6 point. Okay. So okay, then 10 minutes more we can teach. It is 6:40 right now. No, it is 6:31. Okay. So just say me these two numericals you can able to do or not. Calculate the equilibrium constant for the reaction at 25 degrees Celsius. See, the first in the first A, copper 2 plus zinc gives copper and zinc 2 plus. So E naught copper 2 plus, if we just say me which is cathode, which is anode, based upon the reaction. Listen, student. By seeing the reaction, just say me which is cathode, which is anode. The first reaction. The first reaction A, which is cathode, which is anode. Copper is cathode and zinc is anode. So the standard reduction potential of copper is given 0.337 volt, and standard reduction potential of zinc is given 0.763 volt. So E naught cell, you can calculate E naught cell for this one, copper, this minus this. So this minus this is calculated. So here E naught cell is calculated by doing this minus this. You got this value. Then your equilibrium constant K is equal to, so here number of electrons are, number of electrons, who can say number of electrons?
2.
2. So,
2.
so in this formula, if you put 2 into E naught cell, what is E naught cell you got? E naught cell you got 0.1.1 volt into 1.1 divided by 0.059. You will be getting K, log K. So whatever log K you will be getting, students, if you do K equal to 10 to the power 2.2 divided by 0.059. See here, this is the, and in the second one, this is V. What is the number of electrons involved? Fe3 plus 3 plus 2, 2, 2. Here also 2, I think so. Why so? Number of electrons 2. See here. 2. Got it? So here E naught cell is equal to, in this reaction student, who is cathode, who is anode? It is a cell. First one is a cell, second one is an electrode. Or you can say a cell, no problem. See here, Fe2 plus is your cathode and Fe3 plus is your anode. So okay, so here this is Fe gives Fe2 plus, Fe2 plus gives Fe3 plus platinum. This will be Fe3 plus, Fe2 plus. So this is the reaction. This is the, here this is the cathode minus anode. It gives this one. Oh, inert cell is equal to this. How can you got this one? From this detail, from the value. Here the value is given. Here the value is given. This is your cathode. This is your anode. So this minus this. So this, see here, this minus this. That means a 0.771 minus of minus 0.44. 0.7.1 minus of minus 0.44 equal to minus 1.211. 1.211 means here in this equation n is equal to 2 into 1.211 divided by 0.059 is your log k. Students, can you able to do in your question paper, can you able to do?
Yes, sir.
No. Okay, so in this way you can able to calculate the equilibrium constant. So pH also there, but direct numerical I am not getting in your book, but I am having some numericals. Just a minute, let me to check. Just a minute. So student, so let's stop here, and I'll be taking your next class on day after tomorrow, because tomorrow is I will be in as one of the squad in KIIT KIT Star Night, that is Kid Fest is going on, and today is day 3, day 2. I am not the squad today, but I will be squad for tomorrow. That's why only tomorrow is the last day of this function. So day after tomorrow, I will take continuously four more class or 5 more class, whatever are scheduled are given to allotted to me. Okay. So you go through your book and have some doubts and come with the doubts. Okay. So I'm leaving now. Huh? Thank you for joining. And the day after tomorrow at 5 o'clock or before that, you all are instructed to join. Okay.
Thank you, sir.
Thank you. Thank you. Good
Thank you,
night.
sir. Thank you. Thank you.
Okay, I'm leaving. Huh?
Okay, sir.